And in yesterday's lecture, we have seen questions which were based on circular permutations. Today, we are going to continue and we are going to see your last exercise, which is based on combinations. So first we'll see what is combinations, some basic formulas of combinations, and then some word problems of combinations. So should we start? Is my voice audible to everyone? Let me know in the chat box so that I can start. Welcome everyone, Janvi, Rutu, Kashish, Yogita. Good afternoon, Parth, Shreyas, Manas. Okay, there are some few names which are new. Yogita, Manas. So how many of you are attending this lecture for the first time? I think that 3 of them are new. Perfect. Is my green screen visible to everyone?
Yes, sir.
Okay, thank you. Yeah. So we have seen what is a permutation. Our first example for permutation was that of a bomb, where we had to enter the digits in the same order. If we don't enter the digits in the same order, the bomb is going to explode. So in permutations, order was of critical importance. So we can say that permutation is related to arrangements. And we have seen one example for combinations as well. Best example for combinations is a fruit plate, where if we are served with mango, apple, banana, chiku, orange, so we can eat whichever fruit we want to eat first. It's our choice. So if you want to eat banana first, we can eat. If you want to eat mango first, we can eat that. It's not like a bomb that if you eat mango, then you're going to explode or you're going to die. Nothing is going to happen. Whichever is your favorite choice, you're going to eat that. So combination is related to choice, or you can say selection of objects, whereas permutation was related to order and arrangement of objects. Okay, so we'll start with some basic formulas. We know that formula for NPR is equal to n factorial upon n minus r factorial. Combination is represented by C, permutation is represented by P, combination is represented as C, and formula for combination is equal to n factorial divided by r factorial into n minus r factorial. So it is, this part is same as that of NPR. There is one more portion which is r factorial. Therefore, can I say that NCR is equal to, this term is what? NPR divided by r factorial. Or I can get a relation over here. If I shift r bar to r factorial to other side, I will get NPR is equal to r factorial multiplied with NCR. So how do we find this value? Similar to that of our permutations. So if someone has asked to find value of, say suppose find value of 8C7. So it is simple. 8C7 can be written as 8 factorial upon r factorial. What is r in this case? 7. So divide by 7 factorial multiplied with n minus r factorial. That is 8 minus 7 factorial. And what is 8 minus 7? 1. What is 1 factorial? 1. Again, I'll revise all the factorials. What is 0 factorial? 1. What is 1 factorial? 1. 2 factorial? 2. 3 factorial? 6. 4 factorial? 24. 5 factorial? 120. 6 factorial? 720. 7 factorial? 5040. Okay, so let's continue this. I'll simplify this. How can I simplify? 8 factorial is nothing but 8 into 7 factorial divided by 7 factorial into 8 minus 7 is 1 factorial. 1 factorial is 1. This and this will get cancelled out. Hence, I can say that my answer is nothing but 8. Let's say another question. I have to find value of 9C9. Applying my formula, in place of n I have 9, in place of r also I have 9. So formula is n factorial upon r is in this case 9. So 9 factorial multiplied with n minus r. So 9 minus 9. 9 minus 9 is 0 factorial. This and this term will get cancelled out. What is 0 factorial? It is 1. It is not 0. 0 factorial is 1. And 1 upon 1 is going to be equal to 1. Okay. So let's find value of 10C0. So that would be equal to what? N factorial, that is 10 factorial, upon r factorial, that is 0 factorial, into n minus r factorial, that is 10 minus 0 factorial, which is equal to this 10 factorial, 10 minus 0 is 10 factorial, cancels out. 1 upon 0 factorial, answer is equal to 1. Then we'll see, suppose I have to find value of 10C1. What would this value be? N factorial upon r factorial, that is 1 factorial, into 10 minus 1, that is 9 factorial. I can reduce this. 10 factorial can be written as 10 into 9 factorial divided by 9 factorial. This and this cancels out. Answer is equal to 10. So if you see your answers, what is answer of 10C0? Answer of 10C0 is coming as 1. So I can say that even if you try other numbers like 100C0, answer is always going to be equal to 1. 1000C0, answer is 1. So NC0, answer is always going to come as 1 because the terms from numerator denominator will cancel out. So 1 lakh C0, answer is 1. Okay. When else my answer is 1? So this second question, 9C9. So if I say that instead of 9, I can have any other number, 5C5, 10C10, 100C100. When I'm going to solve that, I'm still going to get my answer as 1. So these will help you to solve your questions more easily. Remember that value of NC0 and NCN is always equal to 1. Okay. Is there any other shortcut or formula that will help you to solve easily? Yes. Value of NC1 and value of NCN minus 1 is always equal to N. Okay, what does that mean? See your D option. In D option, what I had? 10C1. And when I'm going to solve 10C1, what did I get? 10. So if instead of 10C1, there was 100C1. After solving 100C1, I'm going to get 100. If there was 9C1, solving 9C1, my answer would be 9. So if there is NC1, my answer is going to be N. Similarly, NCN minus 1. So if consider example number A for that, you have 8 over here, and instead of R, you have N minus 1th term. 8 minus 1 is 7. So if you have one term less, the answer is equal to N itself. So 8C, 8 minus 1, that is 7. So 8C7, answer is 8. 10C9, answer would be 10. 100C99, answer would be 100. So formula for NC1 and NCN minus 1 gives me directly N. Similarly, you can calculate. If you go from extreme sides, you can see that values are going to be always same. So NC0 and NCN, answer is 1. NC1 and NCN minus 1, answer is equal to N. Then NC2 and NCN minus 2, these two values are going to be same. So you can calculate down and remember the formula so that you don't have to solve them each and every time. But you should at least know these 4 values. NC0, NCN, answer is 1. NC1 and NCN minus 1, answer is N. So copy down this much. Let me know in the chat box if you're having any doubts. You have 30 seconds. If there is any particular doubt in question 1, 2, or A, B, C, D, or you have not understood any formula, type in doubt. so that I can focus more on that part. If you have understood clearly, type in understood so that I will proceed. So Muzammil, Aditya, Aryan, Riya, did you understand this part? Okay, so I've got understood from Parth, Aditya, Muzammil, Rutu, Khushi, Aryan. Perfect. So I'll move to next slide then. We'll see few questions from your textbook exercise. Question number 1, 15C11, and question number 1B is 80C2. So I'm not going to solve this. You can solve this later on. I'll proceed with second question. You have to find value of n if 6p2 is equal to n into 6c2. Okay, so how can we solve this question? Left hand side 6p2, apply a formula. NPR formula is n factorial upon n minus r factorial. So 6 factorial upon 6 minus 2 factorial. 6 minus 2 is 4, which is equal to n into 6c2 formula. 6 factorial. NC2 formula is n factorial upon r factorial into n minus r factorial. So that is equal to 6 factorial upon r factorial, that is 2 factorial, into 6 minus 2, that is 4 factorial. Is anything cancelling out? 6 and 6 is cancelling out. 4 factorial cancels out. Therefore, n is equal to 2 factorial. And what is 2 factorial? 2 factorial is 2. So, pretty easy question. 2nc3 is to nc2. This value is given as 52:3. So again, we'll apply a formula. It is in the form of NCR. NCR formula is n factorial upon r factorial into n minus r factorial. So 2nc3, that is going to be 2n factorial upon 3 factorial, that is r factorial, into n minus r factorial, that is 2n minus 3 factorial. This whole term is divided by nc2. Again, apply a formula, that is n factorial upon 2 factorial into n minus 2 factorial, which is equal to how much? 52:3. Okay, let's simplify this. In my numerator, I can say that it is 2n. I will keep on reducing because I have 2n minus 3 over here. Next term would be 2n minus 1. Then I'll have 2n minus 2. And then finally, I'll get 2n minus 3 factorial. We have seen in the factorial exercise. What is 10 factorial? 10 factorial is 10 into 9 into 8 into 7. We keep on reducing by 1. So if I want to reduce 2n, it will be 2n, then 2n minus 1, then 2n minus 2, 2n minus 3. So I can keep on reducing, but I'll reduce till 2n minus 3 factorial. Why? Because in denominator I have 2n minus 3 factorial, and I can cancel this out. Similarly, I have 3 factorial. 3 factorial is 3 into 2 factorial. Divided by n factorial. N can be written as n minus 2, n minus 3, n minus 4. But I'll reduce till n minus 2 factorial only. Why? Because in denominator I'm having n minus 2 factorial, so that this and this cancel out. Also, I have 2 factorial over here, so that this and this cancel out. Hence, I had written 3 factorial as 3 into 2 factorials. What is this equal to? This is equal to 52/3. Okay. So how can I simplify this further? I'll erase this portion. Yep. So next step I'm writing over here. So how can we simplify? I can write 2n as 2 into n. This would be 2n minus term as it is. So 2n minus 1. 2n minus 2. I can take 2 common. If I take 2 common, it will be n minus 1 over here, which is divided by how much? 3. And in my denominator, I have n upon n minus 1. So that can be written over here itself, n into n minus 1, which is equal to how much? 52 by 3. This 3 and this 3 cancels out. This n cancels out. N minus 1 cancels out. 2 2s are 4. 4 1s are 4. 4 13s are. That means 2n minus 1 is equal to 13. 2n is equal to 14, which means n should be equal to 7. So copy down these two questions, and I want you to solve the two textbook questions, which are 80C2 and 15C11. You have 2 minutes for this. If you have any doubts, you can ask. Okay. If anyone is having any doubts, you can ask. Last 1 minute, fast. I want some answers. Okay, Om has given both the answers. Om, I'll write down the formula for NCR, so that formula for NCR is n factorial upon r factorial into n minus r factorial. Drag in. Okay. Muzamil, check your answer again. Kashish, good going. Right answers. Others, good Atharva. Calculate again. Still making some silly mistake. Others? Okay, Atharva. Last 30 seconds passed. It's correct, Atharva. Okay. Om, can you simplify it a bit more? Because most of the terms will get cancelled out. So, okay. Perfect. Pranika, some silly mistake. Try again. Interesting point, Muzammil. But no, that's not the right answer. Formula is simple. MHT-CET. You have to use NCR formula. NCR formula is n factorial upon r factorial into n minus r factorial. Instead of n, you have 80. Instead of r, you have 2. So you just put in the values and try. Try till you succeed. That is correct answer, Kushi. Perfect. Last 15 seconds. Pranika, some calculation mistakes. Try again. Okay, time's up. So pretty easy questions. MHT-CET. N is 80, so that will be n factorial, that is 80 factorial, upon r factorial, that is 2 factorial, into 80 minus 2, that is 78 factorial. I can reduce 80 factorial. I can write 80 factorial as 80 into 79 into 78 factorial. I'll reduce till 78. Why? 2 factorial is 2. Because I have 78 factorial over here. This and this will get cancelled out. 2 ones are, 2 fours are. So 4 nines are 36. 4 sevens are 28. And 3 carry 31 and 0. So 3160. And second was 15C11, which is equal to, instead of n, I have 15, and instead of r, I have 11. So NCR formula is n factorial, that is 15 factorial, upon r factorial, that is 11 factorial, into n minus r factorial, that is 15 minus 11. What is 15 minus 11? 4 factorial. 15 factorial can be written as 15 into 14 into 13 into 12 into 11 factorial. I'll reduce till 11 factorial. Why? So that I can cancel it out from numerator and denominator. And I can write 4 factorial. 4 factorial is what? 4 into 3 into 2 into 1. So 4 3s are 12 and 12 will get cancelled out. 2 1s are 2 7s are 14. And then multiply these terms. After multiplication, you get your answer as 3160 and 1365. Yeah. So this is the answer. We'll see next question from a textbook. You have to find the value of n is equal to question mark when NC n minus 3 is equal to 84. Again, NCR format, I'll use my formula n factorial upon r factorial. Instead of r, I'm having n minus 3. So n minus 3 factorial into n minus r factorial. So n minus 3 factorial, which is equal to how much? 84. I'm having n minus 3 in my denominator, so I'll reduce till n minus 3 factorial term. So I can cancel from numerator and denominator. So n minus 1, n minus 2, n minus 3 factorial. Whole term upon n minus 3 factorial. This and this will get cancelled out. If I open this bracket, what will I get? N minus n cancel out, minus minus plus 3 factorial, which is equal to 84. Therefore, I can say n minus 1, n minus 2 is equal to, I'll write 84 in simpler terms. 84 can be written as 42 2s, 42 is 21 2s, 21 is 3 7s, and this 3 factorial to other side. 3 factorial is 3 into 2 into 1. So why have I written in this way? Because I have 3 consecutive terms over here. So if I split this, I can easily find 3 consecutive terms multiplication over here. So I can see 7 over here. So either my terms will be 6 7 8, 7 8 9, in that way. So let's see. So I have 7, 2 2s are 4, and 2 8, and this 3 and 3 would be 9. So I can represent this multiplication as 9 into 8 into 7. And comparing, I'm going to get n is equal to 9. So I had 3 terms of multiplication on my left. So what I did is, there were multiple terms on my right hand side. So I just wrote them in the form of 3 terms, 3 consecutive terms. So if I write them in 3 consecutive terms, then bigger number should be equal to bigger number, smaller number should be equal to smaller number. So n should be equal to 9, or n minus 2 is equal to 7, which means again n is equal to 9. Or middle number is equal to 8, so n minus 1 is 8, that means n is equal to how much? 9. So copy down this much and let me know if you have any doubts. Okay, Aditya had already given answer of 9. Perfect, Aditya. Others, you have 10 seconds. If you have doubts, type in your doubt, or I'll move to next question. Perfect. No doubts from anyone. Question number 5. NPR is given as a very big number. That big number is 181,4400. Okay. And what you have to do is, you have to find value of n. Also, NCR value is given as 45. Okay, so NPR, NCR values are given. We have to get the value of n. It is simple. What I can do is, I can write NPR as NPR is equal to 181,440. That means n factorial upon n minus r factorial is equal to how much? 181,440. Also, I know value of NCR, which is equal to how much? 45. Therefore, what is NCR? N factorial upon R factorial into N minus R factorial, which is equal to how much? 45. But what is this term value? N factorial by N minus R. I'll say this is equation 1. So from equation, I can see that value of that term is equal to how much? This. Therefore, instead of writing this term, I can write 181,440 upon R factorial is equal to 45. Therefore, R factorial is equal to, divide this, 5 9s are 5 3s are 15, 3 carry, 5 6 are 30, 1 carry, 2s are 4 carry, 5 8s are 40, and then 5 8s are 40. And then cancel this out. After simplifying, you're going to get R factorial as 40320, which means R should be equal to 8. 8 factorial is 40320. Okay. So go through this. If you have any doubts, you can ask. You have 30 seconds. Any questions from anyone? Okay, clear from Prashant. Perfect. So we'll stop here today. Tomorrow or on Monday, we'll see some word problems and few more questions from your exercise 3.6. So tomorrow or the next lecture, which would be on Monday, would be the last lecture for permutations and combinations. So I expect that you complete all the exercises till exercise 3.5. If you have any doubts, take up your doubts, ask me in the next lecture, because next lecture would be the last lecture in which we'll finish up with the chapter. And I think that it's a very interesting chapter. So thank you everyone. See you in the next lecture. Let's follow a regular drill. Let me know in the chat box if you have understood the lecture, enjoyed the lecture. If you had any doubts, type in your doubts in it. Clear. Thank you. Okay. Thank you, Rutu. Thank you, Rishikesh. Thanks, Kushi. Thanks, Pranika and Muzammil. Perfect. Thank you, everyone.